Good morning. I still see a lot of people in the hallway, but let's get started. Good morning, my name is Marit van Dijk. As someone just asked me, Van Dijk, that's from the Netherlands, right? Yes, very much. I currently work as a developer advocate at JetBrains on the Java team. I do have some Dukes on my laptop as well, but I was at KotlinConf recently, so I added a bunch of Kotlin stuff. And I'm here today to talk to you about keeping your dependencies in check. And my first question is, who uses open source software in their work projects or pet projects? That's pretty much everyone. Let me do a check question. Anyone who doesn't use open source? Okay. No one. Okay, cool. So then we're all on the same page here. Open source is great because it offers us a bunch of functionality that we need without having to write it ourselves. So from testing frameworks, application frameworks, and a bunch of other stuff, we basically get it for free because someone is paying for it in the work that they do. But if that's not us, then for us it's for free. But of course there are downsides, because for every direct dependency that we declare, they might pull in transitive dependencies or the projects that they depend on. And the problem with that, as we've seen, is that any of those dependencies can have known vulnerabilities. Not just the dependencies that we declare, but any of the transitive dependencies that they use. We've seen an interesting example of this in December of 21. As I'm sure you remember, as we were getting ready for Christmas holidays, Log4Shell was disclosed. And one of my former coworkers at my previous job is actually a Log4j maintainer who had planned to go on holiday and instead spent 22-hour days fixing this bug for free. So this is your semi-regular reminder to appreciate an open source maintainer today. And the job I was in at the time, they used a microservices architecture, or still do, which meant that every team is responsible for multiple microservices that they build, run, and love in production. And we had to update all of those urgently with a newer version of Log4j. And then we got to do that again because after the first vulnerability was fixed, several others were disclosed, and we got to fix those as well. So urgently deploying all of our, updating and deploying all of our microservices, excuse me. And then, of course, in March, that same colleague wanted to go on holiday again, and Spring4Shell happened. So we got to, again, urgently update and deploy all of our microservices. But the upside was we had just gotten all of this practice, so it was faster this time, right? Yeah, so as we can see, using dependencies has pros and cons, like pretty much everything in software development. There's a reason the standard answer is, it depends. But the interesting part of that answer is always, what does it depend on? And I've seen several ways that teams deal with this uncertainty. I have seen teams that try to use little or no external dependencies and opting instead to write everything themselves. The upside being that they have less packages or external packages to maintain, less trouble of potential clashes between transitive dependencies that are always fun to resolve, and they have more control of the code. Some people are really, really paranoid and they don't trust the code unless they write it. So I kind of understand this, but also if there's a great package, something out there, maybe why not use something standard? Because if you have to write everything yourself, then it's more work. And also there are some things that you don't want to do yourself, like cryptography, for example. I'm not smart enough to do that. On the other hand, there are teams that aren't critical at all of what dependencies they bring in. We have a problem now, we need to fix it, we search Stack Overflow, Some random person on the internet suggests to add this dependency and it will make our current problem go away. Why not do that? But of course, then you have a new dependency that you have to lug around and keep up to date. So saving your or fixing your problem now might bring in problems in the future. So I suggest that we look carefully at the dependencies that we use and that we carefully consider, do we need this dependency? And let's look at some of the things that we want to consider. First off, we want to consider whether this particular dependency is a good fit for the problem that we're trying to solve, and whether the size of the dependencies that we're bringing in is relative to the problem that we're trying to fix. One example that I find a lot is using string utils, which offers some great utility functions for dealing with strings. But if you're only using it for 1 or 2 functions, maybe you can write those yourself, especially if you're moving from Java to Kotlin, like we did in my previous company that I worked for. Often you can replace them with extension functions and get rid of a dependency. Or you might already have a dependency that does what you need. If you have Jackson, you don't need JSON, or vice versa. So make sure to not bring in things that do, dependencies that do the same thing. Also, you might want to consider the impact of bringing in a particular dependency. String utils, like I said, is relatively small. If you, in the future, want to get rid of it, that should be fairly straightforward, especially since I've only seen it used often only in like maybe 2 or 3 places. So it's very isolated. You can easily remove it. Others are more like dandelions. If you have one, you have a gazillion, and they're everywhere, and you can't get rid of them ever again. Ask me how I know. And here I'm thinking of things like Lombok. This example brought to you by my husband, who's also a software developer, who's encountered this when moving from Java to Kotlin and then trying to de-Lombok stuff first. Or Reactor, which will also pretty much influence your entire code base. So if you ever want to move away from that, it's going to be more work. Another thing to consider is how well maintained a particular dependency is. And I'm thinking of frequency of commits and releases. Of course, how well they respond to disclosed vulnerabilities, like Log4j responded very quickly. But also the number of active maintainers and committers, because if there's more people working on it, the odds of stuff getting fixed is higher. And because there's an XKCD for everything, this one is particularly relevant here. There are lots of projects that are maintained by one thankless maintainer for ages. And unfortunately, some open source users can come off as very entitled. Why isn't this fixed yet? Well, because no one has contributed a fix. A term that's often used here is the so-called bus factor, or the number of people that could get hit by a bus before this project goes unmaintained. I have the same, I don't like this, someone is looking very shocked in the front row. I don't like this expression because I don't want to think about people getting hit by a bus. So I've heard an alternative term that I would like to propose we all use, which is called the lottery factor. Unfortunately, I don't remember where I got it from, but the lottery factor means how many people can win the lottery, which is much better than getting hit by a bus. How many people can win the lottery, never have to work on this open source again if they don't want to, and move off to a tropical island or, given the rising water levels, the top of a mountain somewhere, before this project goes unmaintained. Another thing to consider is the community. That's all of us here. If a project is very popular, more people might be speaking about it, writing about it, helping people out in Slack channels or wherever a project communicates with their users, answering questions on Stack Overflow, etc. Some of those users might translate into contributors, but unfortunately not enough ever. So that is something to consider. But also, is the community welcoming? Are they helpful? Are they open to questions? Are they okay helping new users again and again and again with the same questions? Do they have quick starts or tutorials on how to get started to help new users, etc.? Of course, there's a personal element. We all have our favorites, things that we like using or don't like using. So consider whether it's easy to implement, easy to use, whether you like using it. And if you decide that you do want to use a dependency, make sure that you're using the latest stable version and that you're not bringing in vulnerabilities into your project. What are some of the places that we can look for this information? First is Maven Central, which is operated by Sonatype, where we can find what dependency or how to import it into our project, the type of license it uses, the website or the source code where we can find that, and it has a link to the Sonatype OSS index, where we can find whether a particular version, if it doesn't have known vulnerabilities, or whether it does have known vulnerabilities. Another place to find this information is the JetBrains package search website, which is also integrated into IntelliJ IDEA, as I'll show you later. But if you don't have access to your IDE, you can search for information on the package search website. You get similar information there as Maven Central, so latest release, license, who the developers are. Also links to relevant Stack Overflow tags if you want to see what kind of questions there are, how people in the community are responding to those. Links to the website, the source code. And if it's on GitHub, I don't know if you can read that line, but it also has information on the number of stars and watchers and forks. Not that that always means a lot, because I tend to star projects that I would like to look at a later date, if I ever have the time to go down the rabbit hole, which I never do, unfortunately. Also the versions and the release dates, etc., like Maven repository. Of course, we can go look at the source code itself on GitHub or wherever that is hosted. Again, here we can see stars and forks and release information, etc. But also here we can see how the maintainers interact with the community. How do they respond to issues? How do they respond to pull requests? As well as go to insights to see the activity on the project, and contributors to see who contributes to the project and when. So I learned that Jackson is pretty much maintained by one person with occasional contributors, which is kind of scary, considering we probably all use it. So they might want some help. However, we will likely end up with at least some dependencies to maintain, which isn't our favorite thing. We'd much rather be building new stuff, right? And it can be also hard to explain to the business why we need to do this, because it's not currently on fire. It's not urgent to make sure that we stay somewhat up to date with the ecosystem until all of a sudden it is urgent and we can't update because we have all of this other old stuff that we need to update first, because otherwise it doesn't work. Fortunately, there are lots and lots of tools that can help us with that, so let's look at some of those. In the past, I would use Maven. I've used Maven more than I've used Gradle to check what type of dependencies a project has. We can look for the dependency tree, which will tell us our declared dependencies and the transitive dependencies that it brings in. And it shows in a kind of a tree view. We can ask Maven for which dependencies can be updated. But as we can see here, it suggests 2.15 for Jackson, which actually is currently a release candidate. And we can't tell that in the Maven command line. We can also run the command dependency analyze, which will tell us if we have, for example, declared unused dependencies that you might want to remove. By the way, I'm using an example here of a very old project that I built and haven't maintained since, so don't worry, none of this is running in production anywhere. This project is pretty useless, except as the perfect example of extremely outdated dependencies. And also in this case, it says it has JUnit, but it's not being used. In that case, don't delete it, write some tests. But that's a different rant. Gradle has similar commands. You can ask for the dependency tree. If you want to check for dependency updates, you need a plugin like the ban mains one, which is up by a few versions since I created this slide. And if you want to check for unused dependencies, you can use the Nebula plugin unused dependency rule, which I haven't tried out yet, but looks very useful. Of course, in IntelliJ IDEA, you can see which dependency your project uses in multiple ways. I didn't want to run or tempt the demo gods and depend on conference Wi-Fi, so I have slides, but if you really want to see it in action, come find me and I'll try to demo it, network gods willing, because some of these features do need internet connection. So we can, of course, see our dependencies in our build file, so either our POM XML or our build Gradle. You might have seen them in your project window on the left, where you can see all of the jars that you're bringing in. You can open your Maven or Gradle build tool window, where you can see your dependencies, and here you can also expand or collapse them as needed, which is much more difficult in the command line. So that works with Gradle too. And from the Maven or Gradle build tool window, or from the Maven or Gradle tool window, you can open the dependency analyzer, which is the icon I highlighted, which is a magnifying glass and a graph, which will show you the resolved dependencies and their usages. Also, you can open this from Gradle. And here you can search for specific dependencies. If you want to see, for example, where am I getting this particular version of this particular library, you can filter by scope. So depending on whether you're using Maven or Gradle, it will have the Maven or Gradle scopes in that list. And you can look for the ones that have conflicts if you want to see whether those conflicts have been resolved, in which case you'll see that one version has been omitted for conflict. Or if you need to resolve conflicts, this dependency analyzer can help you with that. We can use code completion that we all know and love in IntelliJ IDEA. Who uses IntelliJ IDEA, by the way? I'm just assuming most of you do. Who doesn't use IntelliJ IDEA, just for... Okay, interesting. So you use Eclipse, VS Code. Okay. So in IntelliJ, we can use code completion, which we can also use in our POM XML or our build Gradle to add dependencies. And this is what that should look like, but it won't play for me, apparently. I have links to a bunch of videos. I did videos on all of this on our IntelliJ IDEA YouTube channel if you want to see what that works, how that works, what that looks like. No, here, it should be... Yay. So, code completion, it will insert the right elements for you. You can even add scopes. It will suggest a version. In case of a test dependency, you want to add a test scope. So that's what that looks like. You can also use Alt-Enter. Sorry, one step back. So if a version has newer, or if a dependency has newer versions I can't English today. If the dependency has newer versions available, it will have the yellow squiggly lines underneath. That's the official name for those squiggly lines. To show you, hey, we have a suggestion here, also, as you can see by the little light bulb thingy. And you can use Alt-Enter to get the suggestions that IntelliJ IDEA has for you to fix this problem, which in this case is upgrade the version. Again, this is my old project, so it's still on JUnit 4. Or you can hover over it, and it will show you the suggestion to update to a newer version. Go back. Does it play? No. Yeah. Okay, so that's what that looks like. You can Alt-Enter and go to the next, or select the action you want. So in this case, an upgrade, or hover and upgrade the versions, and you'll see the squiggly lines go away. That works in Gradle too. Then we have the package search integration. Like I said, we have the package search website, but it's also integrated into IntelliJ IDEA, so that you don't have to leave your IDE to go on the internet to look for dependencies, but you can just do that right inside your IDE. So here you can search for dependencies and add them, or you can update specific versions or upgrade all of them. And this is what that looks like. So you can search for a specific version if you don't want to go to the latest. You can upgrade a specific dependency to the latest version, or you can upgrade all of them to the latest versions so that you stay up to date. And also here you can check to only select stable versions so that you make sure to not add release or upgrade to release candidates and that you're using only stable versions for your production code. In IntelliJ IDEA Ultimate, there's additional functionality called Package Checker, where if there are vulnerabilities in a certain dependency, it will be highlighted in yellow. And when you hover over it, it will show you which vulnerabilities are found in that dependency. You can click the links to go to the website to find more information about the CVEs, but you can also see that information right inside the IDE in the Vulnerable Dependencies tool window, where you can see all of the vulnerabilities for your project. Again, old project, with their severity, and you can click them to get the information for the specific vulnerabilities that are found there. Like I said, I have a video series on this on our YouTube channel. So all of the things that we've seen so far are great because you can check it while you're working on a project. But if you work in a microservices landscape and you have multiple repositories you're responsible for, it means you have to go check out each project, check for updates, and then still apply and verify them, which can be annoying and a lot of work. So there are other tools that you can use, which are software composition analysis tools. These tools can scan all of the repositories for your organization, and some of them also scan the containers that you're using. And they can create an overview. So at my previous job, we would have a dashboard for each team of their repositories and the vulnerabilities that were found inside those repositories so that the teams could make sure to stay up to date. So the upside is you don't have to check out your repositories individually and check for updates, but you can see that in the dashboard. The downside is I do still have to take the action of actually checking the dashboard and then taking action on that and still apply and verify those updates. So the next set of tools that we can use are bots. If we're using Java or JVM languages, we have three options, which is Dependabot, Renovate, and Snyk Open Source. Snyk are here, I noticed. So I compared these three bots for you. I applied them to my GitHub repositories, and let's have a look at some of the differences. So Dependabot is GitHub native, which means that it's fairly straightforward to apply to your GitHub repositories if that's what you're using. It offers different functionality. It can provide you with alerts on your repositories. It can do security updates for you, and you can configure it to do version updates if there are new versions, but not for security reasons. Since it's GitHub native, you can enable it in the settings and enable the alerts and or security updates. If you enable alerts, it will give you the yellow box with that there are vulnerabilities found, and you can click the button to see which alerts are there. If you enable the security updates, Dependabot will create PRs for you that will update the version, and then if you have it set up so that it will run your CI/CD automatically, it will check that it still compiles, that your tests pass, etc. And you can see whether it's, or you can guesstimate whether you can or can't apply that update. If you want to apply version updates as well, you need to add some configuration, specify which package manager you're using and where your manifest file is, schedule an interval. You can set the maximum number of PRs so that you don't get spammed with too many updates. And you can set a rebase strategy, which means whether or not it should automatically rebase if you make changes, which might be relevant if you have a set number of cycles on CI to run builds, like we found out on an open source project that I sometimes contribute to. They support GitHub, but I'm I think you can, or I know that you can run it on GitLab too. I'm not sure if they support any other platforms, but if you use GitHub, this is the quickest way to get started with some of this. At my previous job, we used Renovate, which on GitHub is available via an app. It offers security updates and version updates like Dependabot, but also a project dashboard of all of the updates that your project needs. On GitHub, you can use the GitHub app to apply it. They support other platforms that I'll get to. We used GitLab at my previous job, and someone had written some instructions on how to add it to your repositories, which I did for the team I was on at the time, which was fairly straightforward. So to enable it on GitHub, you need to enable the app. Here for Renovate, if you haven't tried any of these tools, Renovate is the only one that allows you to apply it to only one repository. So if you just want to try it out and see if you like it, I'd recommend getting started with Renovate on one repository. It will create an onboarding PR for you with some basic configuration. And once you merge that, it will start doing its thing. It has several configuration options, so you can set it to apply to all of your repositories or only selected repositories. It creates a basic config file for you. You can set scheduling. You can set the maximum number of PRs, but also maximum number of concurrent branches so that you don't have too many open PRs at once. You can use rule-based auto-merge. So if you have specific updates that you'd like to just have applied without someone looking at it, you can configure it to auto-merge those. And overall, it has more options than Dependabot, and the options it has are more fine-grained, so you're more in control. The PRs might look like this. They provide a little bit of information, which versions they're bumping, but also how old the new version is, the adoption rate among Renovate users, the percentage of passing tests among Renovate users, and they provide a confidence level of how confident they are that you can apply this update, where if it says neutral, it means that either they don't have enough information yet, or they can't determine based on the information that they do have. They provide a dashboard for your project with all of the updates that your project needs, which is a lot if it's an outdated project like this one, and a dashboard of the jobs that have run. They support several platforms, including GitHub, GitLab, Bitbucket, and more. Snyk Open Source is available via Snyk. They offer security updates and version updates like the previous two. But in addition to that, a feature that I really like is to test for new vulnerabilities on incoming PRs, because the other two don't do that, which means you could technically add new vulnerabilities in between scans. They also offer to test for vulnerabilities on your source code, but there are other tools that do that too. And they have slightly prettier dashboards than Renovate, in my opinion. You can enable Snyk Open Source via Snyk, which has more steps. You need to authorize them. You can check, or you can select whether to apply it to public and private repositories or public only. You need to set an account and a personal access token. And if you have them enabled, they will start creating PRs as well, where they provide information on why they want to bump a specific version, including links to the vulnerability that was found and that should be fixed by this bump. What they do automatically is bundle PRs of related bumps. You can configure Renovate to do that too, but Snyk does it out of the box. So that helps with getting the number of spam PRs that you get. And like I said, what Snyk does and the others don't is check your incoming PRs for vulnerabilities. And they provide a dashboard where they show vulnerabilities for your repositories. Again, old repositories with lots of vulnerabilities. They have some configuration options, not as many as Renovate, as far as I know. So you can set the frequency. Something that they have and the others don't, as far as I know, is you can select to either update only new incoming vulnerabilities or newly disclosed vulnerabilities, or known vulnerabilities, so you can clear your backlog separately, basically. And they also support multiple platforms, including GitHub, GitLab, Bitbucket. So overall, pick whichever one works best for you and offers the functionality that you need. I've used all of them at some point, and they're all useful. So pros and cons. They're fairly straightforward to add to your repositories. They create automatic PRs for you, so you don't have to actively monitor whether there are new versions available. The tool will do that for you. If it's set up, your build will run automatically. You can see whether for this new version your code still compiles and your tests still pass. However, if that is the case, it doesn't always mean that you can automatically merge and deploy it, because that also depends on the quality of your test suite. I have seen examples where updates have, looked green but weren't ready to be deployed yet. And you still have to actively manage those PRs to decide whether they can be merged, when they can be deployed, etc. And they won't change your code if that is needed. So this is where migration tools come in handy. I'll get to Tim in a minute. One migration tool is the migration refactoring in IntelliJ IDEA that you can use to migrate, for example, from Java EE to Jakarta EE. So that's why I want to share that this exists, because I've done this manually, as I have done a manual upgrade from JUnit 4 to 5, search and replace everywhere. IntelliJ IDEA can do this for you. You can also create your own migration refactoring, but what it does is it will replace the old classes, for example, JUnit 4, with the new classes, for example, JUnit 5. We have some videos on the IntelliJ IDEA YouTube channel if you still need to upgrade from JUnit 4 to 5, or from JAVAX to Jakarta, because I really rather wished I'd known about this before doing it manually. But there are other tools that you can use as well. One tool that technically isn't intended to be a migration tool but can be used as such is ErrorProne. ErrorProne is a tool that is a static analysis tool for Java to catch common programming mistakes. So they have a long list of bug patterns, I think several hundred by now, that they can find in your code, and you can set it to either report on those, or they can automatically fix it in your code for you. And you can also add custom checks. So if you're migrating from one way of writing it to another way, you can use Refaster, which is included in ErrorProne, to write before and after templates that can migrate your code. Sander Mak, who's also from the Netherlands and works at Picnic, has done talks on how they use ErrorProne at Picnic, and he discusses how they've also used it to upgrade Java versions, for example. So that can be very useful, and it can be useful to find bug patterns in your code. And the last tool I want to discuss is OpenRewrite. OpenRewrite is intended to be a migration tool. Hi, Tim. It's a source code refactoring tool. It can do framework migrations, vulnerability patches, and API migrations, and more, I think, by now. It started with an early focus on Java. There's early support for Kotlin. I don't know how evolved that is, but they're actively working on that. Support for Groovy. Python support was recently added, and they're working on a JavaScript support. They have a bunch of existing recipes that you can use. Migrating Java versions, migrating frameworks like Spring or Quarkus or Micronaut, as well as fixing check style violations and common static analysis issues. So if your SonarQube is yelling at you, you can use OpenRewrite to help fix that. A bunch of other recipes in their catalog, and you can write your own recipes. And if you want to know more on OpenRewrite, you can go to Tim's talk on Friday. And we're often in the same conference, so I always get to point people to, please go see Tim if you want to know more. So in conclusion, I hope that you will evaluate and re-evaluate the dependencies that you're using, automate checks and updates as much as you can, and stay safe. If you want to know more, I have recordings and slides of previous versions of this talk, as well as the slides for today. If you didn't get all of the links that you want on my website, I'll give you a second. And I just wanted to take this opportunity to do a quick plug, because I will be back in the UK in June to do a session on code reading at the Socrates UK Training Day, along with some very, very amazing people. So please come to the training day and the unconference. And I will leave this up if anybody didn't get that yet. And please let me know if you have any questions for me now, or come find me during the conference. I'll be here today and tomorrow morning. I have to leave at some point during the day tomorrow. Thank you. Discussions. Let's go. Yes.
Which one of these bots or tool migration tools are actually working for transitive dependencies as well? So let's say that it's log4j and you have a dependency that uses log4j transitively. Do they catch these?
That's a good question. As far as I know, disclaimer. So the question, in case the recording didn't catch, do any of these tools catch transitive dependencies as well? So as far as I know, for the bots at least, it will check your build file and upgrade those dependencies. As far as OpenRewrite, Tim is sitting behind you and smiling, so...
Working on a bot, we do cover that, but we don't have the bot out in public yet.
So OpenRewrite is working on it. Thanks, Tim. Anyone else? All right, well, enjoy the rest of the conference, and yeah, please come and find me if you want to have a chat on this or IntelliJ IDEA. Thank you.